Hey everyone, welcome back to the channel where we uncover the incredible engineering behind the world's most massive machines and structures. Today, we're tackling something truly colossal: how the world's strongest anchor chains are made. Imagine a chain where each link is as big as a person, forged to survive the harshest conditions on Earth. If you've ever wondered what it takes to create these unbreakable giants, stick around because we're diving deep into the entire process, from raw steel to certified sea-ready strength. Manufacturers select top-grade alloys, often marine-grade carbon or alloy steels, designed for extreme toughness and corrosion resistance. For the strongest chains, they use high-tensile steels that can handle grades like G70 or higher, which means they're quenched and tempered for superior strength-to-weight ratios. These steels come in the form of massive bars or billets, sometimes weighing several tons each, sourced from mills that hot-roll them to precise dimensions. Quality is key here. Every batch is tested for chemical composition to ensure it meets international standards like ISO 17004 or DIN specs. Once the steel is selected, the preparation phase kicks in. The bars are cut to exact lengths using heavy-duty saws or shears, following detailed blueprints that specify the chain's diameter, often ranging from a few inches for smaller vessels up to over 6 inches for the giants used on oil platforms. After cutting, the pieces might be punched or pre-bent slightly to prepare for the real shaping. It's like prepping dough before baking a massive loaf. Get it wrong, and the whole thing falls apart. The steel bars are loaded into enormous industrial furnaces, often gas-fired or induction-based, and heated to blistering temperatures between 1,200 and 1,300 degrees Celsius. At this point, the steel glows a brilliant orange or white, becoming malleable like putty in a giant's hands. Once it's at peak temperature, the bars are quickly transferred to hydraulic presses or massive forging hammers that can exert thousands of tons of force. These machines bend the heated steel into the classic oval link shape, first into a U-form, then closing the ends. Studless chains skip this for more flexibility, but they're still forged with precision. It's an awe-inspiring sight: sparks flying, hammers thundering, all to create links that could each weigh as much as a small car. This is where the chain starts to come together, literally. 4 stud links. The stud is welded in place if not already forged integral. This creates a seamless joint stronger than the base metal itself. Non-destructive tests, such as magnetic particle inspections or ultrasonic scans, are done right after to catch any flaws. Imagine welding something that has to hold back the force of a tsunami. Precision is non-negotiable. The links are reheated slightly and pass through trimming machines that shear away excess material from the welds, called flash, leaving a smooth, aerodynamic surface. Every link is then measured with calipers or laser scanners to ensure it meets tight tolerances, down to fractions of a millimeter. It's like fine-tuning a symphony. Every note, or link, has to be perfect. The assembled chain undergoes normalizing to refine its grain structure and relieve stresses, followed by quenching, dunking it in water or oil to rapidly cool it and lock in hardness. Then comes tempering in controlled ovens to balance that hardness with toughness, preventing brittleness. Temperatures are precisely managed, quenching from 900 degrees Celsius, tempering at 400 to 600, to achieve the ideal properties. Protection against the elements is next, because even the strongest steel rusts in salt water. For even better performance, options like ArmorGalv use thermal diffusion with zinc powder at lower temps, or Galfan adds aluminum for superior marine resistance. Some chains get multi-layer epoxy and polyurethane coatings for extra durability, or even self-healing tech that repairs scratches. This is where manufacturers prove their mettle, literally. Breaking tests snap sample links to confirm ultimate strength. Chemical analysis verifies the alloy, and every length gets a unique ID for traceability. Phew, that's the incredible journey of how the world's strongest anchor chains are made. From humble steel bars to ocean-conquering titans. These chains aren't just metal, they're engineering marvels that keep our global trade afloat, securing everything from cruise ships to offshore wind farms. If you enjoyed this deep dive, hit that like button, subscribe for more behind-the-scenes engineering, and drop a comment. What's the next massive machine you want us to explore?